Hello, it is I, Dr. Brian Lorgon111, coming at you again with more developer commentary where I am explaining more of the implementation of the vanilla swirl map, the procedurally generated CTM map that I have made, and we're going to dive right into the code. We're going to get more into the meat of it today, although there's still a whole lot to do after this, but let's go ahead and get started. Okay, so let's change to looking at the code, and I've got some of the code from kind of the main method that drives everything, where you can see the way that I have broken down the overall procedure of taking a pre-generated vanilla map and converting it into a vanilla swirl map. And basically, there's a bunch of functions here: treeify, remove trees near spawn, place teleporters, vanilla dungeons, daylight ring, gets double spawners, substitute blocks, etc., etc. And I guess I'll just kind of do a very brief overview of what these things do, and then we'll dive down into some of the pieces of the bits. Treeify is a complicated one that basically tries to find all the trees on the map as well as all the leaf blocks on the map and assign leaf blocks to its kind of like ownership tree stump so that I can do things like remove trees and change the colors of the leaves of the trees and different things. Remove trees near spawn does exactly what it says, basically where I'm going to place the monument at spawn. I don't want any tree cover that's there, and so I remove them. Place teleporters goes and puts the teleporters in the four corners of the map, as well as the different path blocks that lead up to it. Double spawners is the thing that basically takes a vanilla dungeon that has like a spider spawner in it and turns it into an extra hard dungeon with the spider spawner and a skeleton spawner in it, for example. Substitute blocks is the thing that like changes all the stone in the world to andesite and changes certain pockets of ores into spawners and adds coal blocks and stuff like that. Find cave entrances near spawn is locating where to put the glowstone pillars for the interesting cave entrances so that rather than people having to hunt around for the cave, they can just go find where to go ahead and dive in. Find some mountain peaks is the thing that both finds a tall mountain to put the hidden elytra chest in, as well as all of the mountain peak dungeon spawners. Find underground airspace connected components is the thing that does the cave dungeons, the green beacon and the purple beacon. Find some flat areas is the thing that does the red beacon dungeon. Replace some biomes is the thing that turns some plains and desert into hell biomes or end biomes and changes the trees and the actual biomes for the spawning monsters. Add random loots is the bonus monument kind of stuff, like all the hidden chests that are, in trees and lakes and waterfalls all around the world. Place compass commands is the thing that does the divining rod, and I showed in a previous episode, like puts all the colored stained glass and stained clay at the bottom of the world. Place starting commands is the thing that actually builds the monument, as well as underneath the monument there's a bunch of command blocks, and so it puts all of that stuff in the world. Discover and fix tile entity errors is basically I discovered at some point that I was writing bad data to the Minecraft map files. Unfortunately, Minecraft crashed on me at one point, but for example, in the Mountain Peak dungeon, there's like a slab of bedrock that the loot box on the top sits on, and the slab of bedrock like ended up overwriting one of the mob spawners I'd already placed, and so there was tile entity data saying that there was a mob spawner here, but when Minecraft tried to go and like pick that tile entity, like it was just bedrock, and yeah, that caused Minecraft to crash. And so I added a bunch of extra diagnostics for discovering when I was making those problems and fixing them. Relighting the world I've talked about is basically just recomputing lighting because I'm making a whole lot of changes and I'm changing blocks and removing trees, and so I need to recompute the lighting in the whole world. And yeah, saving files and then writing out the map PNG images is basically there's some files on disk that I write, but then I also make the in-game overview map that we just saw at spawn, which basically goes and writes some artificial map files to disk, and then at spawn and place starting commands, it actually has the map item frame entities that hold those maps so that they actually get displayed at spawn. So that's kind of an overview of kind of like the big picture of what all the program does. And now we'll start diving into a few bits of it. So the first bit would be treeify. I'm not actually going to show you the code for treeify because it's a big, horrible mess, but I will instead show you some screenshots that if you followed me on Twitter 7 or 8 months ago, probably, you may have already seen these screenshots. But basically, it's a bunch of trees in the world with the trees replaced with the leaves replaced with either wool or stained glass. And it was as I was testing out these algorithms to try to assign ownership of the leaves in the world to what tree actually owns them. And there's probably some simple, straightforward heuristics one could use. I had an idea for a basic algorithm where you like start at the logs of the tree and then you kind of like work your way outward iteratively to try to claim the leaves. And so whatever log is closest ends up claiming the leaves. But Minecraft ends up being a whole lot more complicated than that. And yeah, trees can kind of overwrite each other, and then there's like two, different types of leaves because you could have an oak tree next to a birch tree, and sometimes they end up kind of like going through each other, and so like the birch leaves aren't even completely connected, and some of them will be embedded inside the oak tree leaves and all kinds of things. And so I basically had a bunch of algorithms and heuristics to try to untangle it all so that if I wanted to remove this particular tree, I would get that particular tree and its leaves and not other connected leaves that belong to other trees. So it's a big ugly mess, and I ended up spending like 2 weeks on it. So that was treeify and the overview code, and now I can move forward to remove trees near spawn, which is now very simple, which is basically I have a tree removal radius, and I just iterate over x and z from like -15 to +15, and all trees.remove xz, the map and the height map. I just go and remove all the trees in that region, and so each tree like knows where its kind of like stump is in terms of x and z coordinates, and so I can just find all the ones that are right near 0, 0 in the center of the map and just remove them. So that's great. The next bit of code we'll look at is place teleporters, and I guess before I jump into this code, let me show a screenshot of what some teleporters look like in the map, just to remind you. Basically, there's like a bedrock box and a beacon, and there's some path blocks kind of leading up to it, as well as some arrows that are kind of pointing at it. And so those are all the things that we need to do. And so looking at the code for place teleporters, I've got it like over a few different screenshots because it's a long bit of code, but there's stuff. Each teleporter unlocks a villager at spawn, and so there's 4 different villagers, and they have different professions and names and different things they're buying and selling in terms of the potions. And I kind of like randomize and shuffle those villagers up and yeah, figure out kind of the appropriate teleportation commands to have the villager be in exactly the right location in the teleporter hub. And then if we go to a different section of the code, basically the thing that actually builds the teleporter, which is like, like a bedrock box, it builds kind of a platform at the base and builds the walls and the sides, and originally I just had them kind of like being open and you could just like walk right into the end gateway, but then I discovered that there was a bug where if you were riding a horse and you tried to teleport, you would run into a lot of various issues or whatever, and so I didn't want people riding horses and running into the teleporter, and so I changed the entrance to the teleporter to be like a plus sign kind of shape that the player can fit through, but a horse can't because it's too narrow for the horse. But yeah, it's just kind of like the bedrock and air pattern that ends up making the teleporter box itself, as well as the end gateway, which is the block that actually does the teleportation. And then it has like exact teleport coordinates where it teleports you back to the teleporter hub back at spawn. And then there's a bunch of command blocks that start out above the teleporter, and I'm not going to show the code for all of those, but basically they go in when the player gets near enough to the teleporter, it goes and unlocks it and adds the villager back at spawn and, does all that kind of stuff. Let's move on to the actual paths. So basically, no matter what type of terrain the teleporter is in, I want to have some kind of path markings on the surface that lead up to it. So if you're anywhere within a few hundred blocks of the teleporter, you might stumble across the path and as a result be able to be led to the teleporter. And so it's basically another example of block substitution. And so if there's stone on the surface of the ground, I will turn it to dirt. If there's grass on the surface of the ground, I'll turn it into a grass path. If there's dirt, I'll turn it into mycelium. If there is sand in the desert, I turn it into upside down sandstone stairs. Some people have seen that before and wasn't sure what it was. And basically, upside down sandstone stairs, the top surface is relatively similar color to sand, but looks a little bit different. And in general, I tried to choose blocks that would stand out if you were looking for them, but some of them kind of blend into the surroundings or whatever. And so there's just a bunch of block substitutions here. And so basically, if at any point I'm trying to draw a path at a teleporter, and this is what block is on top of the world, here's the block that I'm going to switch it to. And so stained hardened clay, becomes hardened clay. And so if you're in a mesa and you have, like a particular color of clay, it's going to turn back to the default red hardened clay, et cetera, et cetera. And yeah, and then there's special casing for like water on the ocean. You might have seen have like ice paths kind of under the water that point to the teleporter and things. And then looking at some other code, then I call them chevrons, like the little arrows that are pointing at the teleporter. Like occasionally every 30 blocks, I end up drawing one of those. And otherwise, I just have little random kind of like bits of the path. And so there's like a 5 wide path, and it like chooses a random block in that width to then do the substitutions, unless it's at the certain distance where it decides it wants to go and make one of the chevron arrows, in which case it's kind of like hard-coded to substitute those particular blocks. And yeah, that's kind of an overview of what's going on there. And so once again, here's a screenshot of it in game where you can see the little chevron arrows that are, every 30 blocks out from the teleporter, as well as just the other little random bits in the path. And I don't remember if the code was ever on the screen, but there's special case too. While it's changing out the blocks on top, like it also like removes any snow that's on top so that you can actually see it. And I don't remember if we saw the code that removes the trees all along the path, but you can see that there's no trees that are covering up the path blocks that are here on the surface of the world because I remove all the trees as I'm building the path as well, etc. Moving on to a different piece of the code, we have double spawners, which is the thing that turns a normal vanilla dungeon that might have a spider spawner into a beefed up one that has, a spider spawner and a skeleton spawner in it, for example. And this one's pretty simple. I just walk over the entire map. I don't walk over the entire map. I only go up to a height of Y of 80. And so if you find a spawner in a mountaintop, it'll just have one spawner in it rather than two. But I walk over the entire map from, X from minimum to the maximum, and from Z to minimum and the maximum, and then from Y from 79 down to 0. And I take a look at every block in the map, and if it happens to be a mob spawner, which is block ID number 52, then I will take a look at what its spawn data is and figure out what type of thing it's currently spawning. And I will add another spawner above it, right above it. And and the mob spawner that I actually add is Vanilla Dungeon Extra, which I think we saw back in the previous episode. And so basically that's the thing that has the logic of here's the original kind of spawner and here's the extra spawner I'm going to place above it, so that I can just kind of, tweak that data somewhere else if I just want to easily change this without going into the guts of the code. And yeah, that's kind of most of an idea of what's going on there. Next, let's look at block substitution, which is the thing that changes like all the stone into andesite, or all of the diorite into silverfish monster eggs. And it's pretty straightforward. It's the same kind of thing where basically I walk all of the blocks in the world, and so there's a giant loop of Y from below Y to high Y, and X from low X to the maximum X, and Z and so that ends up being, if it's 2048 by 2048 by like 128 blocks or something that I'm going through, that's, I forget what it is. It's like 4 billion blocks that it has to walk over. But basically, yeah, check every block in the map. And, if it's a piece of diorite, then turn it into a silverfish monster egg. And I'm using custom terrain generations when I actually like start with the vanilla world or whatever. Like I have the diorite rate at a certain rate, and I have the granite rate at a certain rate, and at certain heights and different things. And so, vanilla Minecraft is giving me the distribution, and then I'm going and actually tweaking it. And so granite only appears occasionally in the map, but it ends up being replaced with spawners. And yeah, and so can I place a spawner? It's something that basically I try not to place two spawners right next to each other because granite, whenever you put ores or things like granite, like in the Minecraft customization settings, if you tell it to spawn in chunks of 1 or 2 for whatever reason, it never spawns any. If you tell it to spawn in chunks of 3, it will usually spawn chunks of 1, but occasionally 2 or 3, kind of globbed together. So I don't know why the code like works this way, but basically I tell it to spawn in chunks of 3 so that I mostly get just like one granite block here and one granite block there. But occasionally there'll be 2 or 3 next to each other, and so it can place spawner, like make sure that I'm not trying to place too many right next to each other. And then, yeah, and then there's this special casing for if we're in daylight near the spawn radius, or near the daylight radius, like inside the circle of daylight near spawn, because on 2 different maps, when I was just testing out lots of different maps, like there's the monument at spawn, and then right next to it on the surface, there was like a stone patch, and there was a monster spawner right there. And it seemed ridiculous to have a zombie spawner out in the daylight right next to you when you started the map. And so I ended up special casing it to say, if there is any skylight, which is the sky getting the nibble array of skyrelate or whatever, like looks up the skylight value at that particular value, and I'm actually trusting Minecraft's value because I haven't recomputed it here. And if the skylight is non-zero, which means there's any sunlight shining on this block, then don't actually change the spawner there, and so just put andesite instead of a mob spawner. And so basically what that means is when you're inside the daylight radius, there won't be any spawners on the surface of the world, but when you go outside of it, especially if you're in extreme hills or other places where stone is just exposed to the world, then you may have encountered spawners just sitting, you know, like embedded in the ground or whatever, like on the surface of the world. And yeah, that's just because it used to be granite and the granite got substituted out for a mob spawner. And yeah, so that's part of substitute blocks. Was there anything else in substitute blocks that I wanted to show off? Oh yeah, in addition to substituting blocks, then there's also code that, for example, in abandoned mine shafts, there are minecart chests. And minecart chests are not blocks, they're entities. And so I have to walk through all the regions and walk through all the chunks and walk through all the entities in those chunks and discover if it's a minecart chest. And if it is, then by default, in vanilla Minecraft, it would have a loot table and a loot table seed, and instead I go and replace those with a set of custom items and a custom name of the chest that says like spooky Minecraft or minecart chest or whatever it says. And yeah, and then I am not showing the code here, but there's a similar thing that when it was walking through all the blocks, it tries to find all the vanilla dungeon chests and replaces those with my own spooky dungeon loot chests. So yeah, basically straightforward idea. Basically walk over every block and every entity in the entire world and do some replacements. So that tells you a little bit more about the code. There are still some more bits to get into, especially the interesting bits that actually make the various dungeons, as well as people ask for just kind of like also an overview of the human process, because there's a lot of human steps that I need to do in order to pick a seed and generate the maps and all that kind of stuff. And so I'll talk about that at some point in the future. In any case, I hope that you guys are enjoying this. I hope you guys are having a great day, and I will see you again soon with more developer commentary explaining how I made this crazy map. Bye-bye.